Very good evening, guys. How are you? I hope you all are doing fine, are completely focused towards your gate preparation, enjoying your gate preparations, and are healthy, wealthy, and wise. So, I am Manish Mishra. I welcome you all to the 35th lecture in the Industrial Engineering Operations Research Crash Course series. Although it started as a crash course, but now it has become a sort of a extended full course, you know. I mean, we have discussed each and every topic thoroughly. That's why this series has gotten stretched up to 35th lecture, and it might went to 50 lectures by the completion of the entire module. So I welcome you all to the 7th lecture of the series. For those who don't know me, let me introduce myself. My name is Manish Mishra. I secured an All India rank of 568 in GATE 2015. And my friends, since then I have been teaching primarily for GATE and ESE. The subjects that I take are manufacturing science, industrial engineering, operations research, as well as material science. I have a cumulative experience of 5 years now in the GATE and ESE sector. And I have mentored over 10,000 plus students in the past 5 years and have an experience of running my own GATE Academy, GATE Institute, that too in a city like Chandigarh. Good evening, Ashwin. Sir, what is game theory and what about the 9:30 class? Ashwin, game theory is not in the syllabus of GATE and ESE. That class is for SSC JE students. So you do not have to worry about that. Okay? That class is for the college students as well as the university students as well as for the SSC students. And the class is not at 9:30, it is 10:30. So let us move on then. Let us move on. So guys, if you do not know about this, I have started a series by the name of Manufacturing 2020 on the Unacademy special classes, which is absolutely free. The entire objective of this series is that in just 20 days time we will be targeting 20 marks in GATE. So in just 20 days time I will be targeting the entire manufacturing, and right now my friends, we are on time, we are going as per the schedule. I have already provided the schedule to my respective students. This series started on the 10th of December 2020, and every day from 9 a.m. to 11 a.m. I go live on the Unacademy app and we are studying manufacturing there. So every day 2 hours. Okay. So this is a very short course on manufacturing, but it will be targeting 20 marks in just 20 days. So guys, this is the entire schedule of this Manufacturing 2020 series, and in this series, my friends, we have completed up to welding and we will be starting metal forming in the next session. So those who have not yet enrolled for this class, go enroll for these classes. And how to do that? Well guys, this is my profile on the Unacademy app or on the Unacademy website. I am a verified educator on the Unacademy platform and I have a ranking of 99 out of 1000 plus educators in the GATE and ESE category on the Unacademy surface or platform. So my friends, in just 30 days time I have reached to this milestone, and it would have been impossible without the support and love of you guys. So those who want to watch my sessions, guys, you can simply scan this QR code using your mobile phones and you will be directed towards this profile page. Simply follow me there and you will be able to get the notifications of all my classes on the Unacademy app. My friends, when you will be joining or when you will be registering for the Unacademy app and when you will be watching my special classes, there will be a prompt that you will have to unlock your free plan. Okay, so special classes, although they are absolutely free, but in order to unlock your free plan you will have to use the referral code MMM10. So remember, use the code MMM10 to unlock your free plan on the Unacademy app. Okay, now a lot of students ask me about the PDFs, notes and practice booklets of my session. So guys, you can scan this QR code and you will be joining my Telegram channel. This is my personal Telegram channel where I daily upload the notes of my class, where I share practice booklet of the respective subjects, and I share the notifications also of my classes and many more things. Okay, recently I have formed a group on the Telegram, a chat group where students can discuss their doubts and we can have elaborate discussions on their career strategies as well as their preparation strategies. Okay, so I will be providing the link of that chat group on this Telegram channel. So guys, if you want to be a part of that doubt and discussion group, and that is by the name Unacademy discussion by Manish Sir. So if you want to be a part of that chat group, first you will have to scan this QR code using your mobile phone camera and you will have to join the Telegram channel. Okay, my friends, now let us start the series. Let us start today's lecture, the 7th lecture on the linear programming problem chapter. Okay, so yes, we are dealing with linear programming problem and today is going to be the last session in this series. Today is going to be the last session in this series. So let's not waste any more time and let me just straight away jump into that. Okay, so friends, in the last class, we discussed about the concept of duality in LPP. So remember, every linear programming problem is called as a primal problem and every primal problem has a dual problem, which is a different problem, has a different perspective, but the variables, the elements in it are basically the same. The data that it uses is basically the same. Now the concept was that if you solve a linear programming problem using the simplex method, then the dual problem automatically gets solved. Okay, so guys, with that we were about to study three things. In the last class I discussed this thoroughly that we are about to study three things in the duality system. And what is that? Number one, how to formulate a dual problem. If you have a primal problem, then how to write the dual problem. Okay, the second thing, how to find the solution of the dual problem once you have solved the primal using the simplex method. And third was how to find the significance, how to understand the significance of the dual problem using the significance of the primal problem. So guys, now one by one we will be looking into it. So in yesterday's class I gave you some notes, and in these notes I basically gave you 7 points which are nothing but seven rules to convert the primal into the dual. So today what I will be doing, I will be taking one question, and with the help of that question, my friends, with the help of that question, I will be explaining you all these 7 rules. So this question is very unique. It is somehow being using, this question is somehow going to test all the 7 rules that are there to convert a primal problem into a dual problem. So let us take the question then, है ना? So the question is to minimize z equal 3x1 minus 2x2 plus 4x3. Let us not take too much space, otherwise I won't be able to fit the entire thing in one page. Then this objective function is subjected to 3x1 plus 5x2 plus 4x3 greater than equal to 7, 6x1 plus x2 plus 3x3 greater than equal to 4, 7x1 minus 2x2 minus x3 less than equal to 10, and at last I have x1 minus 2x2 plus 5x3 equal to 5, and now I will be writing x1 x2 greater than equal to 0. Okay, so now guys, focus, 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 focus. Okay, so the thing is that this problem that we have here right on our screen is basically a primal problem, because remember, every LPP that we have is called as a primal. Now I will be telling you guys how to write the dual of this primal, and meanwhile I will be telling you which rule is getting implied in these conditions. So remember, there are 7 rules. We have already written those 7 rules, and today we will be discussing each one of that rule using this question. Okay, so now one of the rule out of those 7 rules, it says that if the primal is minimization, then my friends, the dual will be maximization. If the primal is minimization, the dual will be maximization. Okay, now, and the vice versa. I mean, if the primal is maximization, dual will be minimization, or if the primal is minimization, dual will be maximization. So let me just show that rule to you. The maximization problem in the primal will be minimization in the dual, and vice versa. So this rule is already over. So as I will be telling you the rules, I will be underlining those rules as well. Okay? So the maximization problem in the primal will be minimization in the dual, and vice versa. Now, there is one more rule which says that all the variables, whether in primal or dual, must be non-negative. All the variables, whether in primal or dual, must be non-negative. That means they should be constrained, they should be restricted, they should not be unrestricted. Okay, so what was the meaning of unrestricted variable? The variables which will not be lying in the first quadrant, are unrestricted variable. So now check this question. This is x1, x2, x3. So there are basically 3 variables in this problem, and as you can see, only x1 and x2 are greater than equal to 0. As my friend, I have said that this question is going to test all the 7 rules. So I have made a promise, and I will make sure that promise gets fulfilled. Okay, so remember, x1 and x2 are the only variables that are constrained, but x3 is one more variable that is there in this problem, but it is not restricted. Now we will have to restrict x3. So what I am going to do, I will be replacing x3 by x3 dash minus x3 double dash, where x3 dash and x3 double dash are going to be restricted variable. Okay, so the reason is that, let's say x3 is negative, it is not in the first quadrant, so the value of x3 can be minus 100. But remember, the variables that are present in the question cannot be negative. So we will get replacing x3 by x3 dash minus x3 double dash, where x3 dash will be having a positive value like 100, and x3 double dash can have a positive value like 200. But the difference of x3 dash and x3 minus double dash, that is 100 minus 200, will be minus 100. So I hope you people understood this point. So now let me just make the conversion. Okay na? So x3, let me use the eraser. So this x3, it gets replaced by x3 dash minus x3 double dash. Similarly, everywhere where there is an x3, it will get replaced. So this will become x3 dash minus x3 double dash greater than equal to 7. This will become 3x3 dash minus x3 double dash greater than equal to 4. this one will become x3 dash minus x3 double dash less than equal to 10. This one will become x3 dash minus x3 double dash equal to 5, and I will be writing x3 dash minus x3 double dash x1 x2 all greater than equal to 0. So up until this point we have already discussed two rules. Now rule number next. So the next rule says that the maximization problem has all the less than type constraint, whereas the minimization problem should have all the greater than type constraint. Okay, so now let us see this. It says that if you have a minimization problem, then all the constraints that are there, they should be of greater than equal to type. If some constraint is not greater than equal to type, you need to convert that. So minimization greater than equal to, maximization all the constraints should be less than equal to. Whether it is primal or it is dual, this condition should be satisfied, that all the constraints should be greater than or equal to in minimization and less than equal to in maximization. If it is not, you will have to make the conversion. So now let us check this. This is the case of minimization. So this is already greater than, this is already greater than, this is less than. So I will convert this. So in order to convert this, this will become minus 7 plus this will get inverted and this is minus 10. I hope you people are getting my point. I hope you people are getting my point. Now my friends, we have converted this one. Into greater than equal to, but this my friend is equal to. And remember, we have to convert every constraint into greater than equal to if it is a minimization case. So this equal to should also be converted. So how to convert this? Just check this out. Okay. So I will be writing in place of this x1 minus 2x2 plus 5 x3 dash minus x3 double dash greater than equal to 5, and then I will be writing x1 minus 2x2 plus 5 x3 dash minus x3 double dash less than equal to 5. Okay, so I hope you all are getting my point. What I have done here, basically my friend, this equation which I am going to underline in red, this is the equation of a line. It is a linear equation. You can see the equal to sign here also, and all the variables have a degree 1. So it is a linear equation, a degree of 1. So basically what I have done, if I want the equation of a line, so I have taken two equations instead of that. One which shows that all the points are greater than equal to this, and the other one shows that all the points are less than equal to this. So basically what happens, the feasible region or the common points become the line itself. So although I have converted this equation into two equations, but still I have only one equation. So I hope you people understand this concept, and let me just rub it so that I can continue. Now my friends, while doing this conversion, what has happened, that I had to make sure that all the constraints in the minimization case are greater than equal to. But in this case what happened, this has become less than equal to. This has converted into less than equal to. So let me just make the conversions here. So this will be with a minus sign, plus sign. I have to use the black color. I am using the red color as an idiot. Minus, plus, minus, greater than equal to minus 5. So guys, yes, so one condition, one rule more has been followed. Now let us move on. Good evening, Fundu and Fact. So let us move on, let us move on, let us move on. Let us check one more rule. Let us check one more rule. My friend, this rule says that if the primal has n variable and m constraint, dual will have m variable and n constraint. If the primal has n variable and m constraint, dual will have m variable and n constraint. So let me just tell this condition to you. So basically what it says, that count the number of constraints. So I have 1, 2, 3, and remember, in place of this one, in place of this constraint, I will be using these two constraints. Okay, so I have a 4 and I have 5. So there are 5 constraints here, 5 constraints in the primal. So what it says, that if there are 5 constraints in the primal, there will be 5 variables in the dual. If there are 5 constraints in the primal, there will be 5 variables in the dual, है ना? Now let us count how many variables are here. So I have x1, x2, x3 dash, x3 double dash. 4 variables are there. So it says if there are 4 variables in the primal, then there are 4 constraints in the dual. There will be 4 constraints in the dual. Okay, so I hope you people understand this condition also. Now guys, I am going to straight away write the dual problem. I am going to straight away write the dual problem. Enough of the pre-preparations. So now what I will be doing, if this is minimization, this is going to be maximization. If this is z, so let me just write w here. So we will be maximizing w. And how to write the objective function? Guys, you just simply have to take the RHS of the constraints. These values that I am encircling, the values that I am encircling will be helping you to write the objective function of the dual. So I will be taking this 7 and I will write a new variable y1, then 4 y2, then minus 10 y3, then plus 5 y4, minus 5 y5. Okay, so this is the objective function, and as you can see, we expected 5 variables. So there are 5 variables, y1, y2, y3, y4 and y5. Now I will be writing the constraints of the dual. I will be writing the constraints of the dual. How to write the constraints? Just check this out, my friends. I will be using these values: 3, 6, minus 7, 1, minus 1. All the coefficients that are of x1, all the coefficients that are of x1, I will be using them. So this 3 will go here and I will be writing 3y1. This 6 will go here and I will be writing plus 6y2, then minus 7y3, then plus y4, minus y5. And remember, all the constraints in the minimization are greater than equal to, and therefore in maximization they will be less than equal to. So this 7, my friend, it went here. So this 3 will go here, the right hand side of the constraint of the dual. So I hope you people are getting my point. I hope you people are getting my point. Okay, so now, like guys, let me proceed then. So now I will be writing the second constraint. So I will be using these values here. So this will be 5 y1 minus y2 plus 2 y3 minus 2 y4 plus 2 y5 less than equal to minus 2. Then I will be writing 4y1, 3y2 plus y3, 5y4 minus 5y5 less than equal to 4. And the last I will be writing, because remember there will be only 4 constraints, है ना? So this will be minus 4y1 minus 3y2 minus y3 minus 5y4 plus 5y5 less than equal to minus 4. And at last I will be writing y1, y2, y3, y4, y5 all will be greater than equal to 0. So guys, this is the final conversion. This is the final conversion. As you can see, 5 variables are there, 4 constraints are there, and I have satisfied that all the variables are restricted, that is they are in the first quadrant. So guys, sir, what does the meaning of primal equation? Fundu and fact. I mean, please tell me your real name, man. What is fundu and fact? I don't even look good saying in front of a camera fundu and fact. So fundu and fact channel. Primal problem is basically your original LPP. So any LPP you have, whatever linear programming problem we have solved up to now, it can be called as a primal problem. And the concept is that every primal problem has a dual problem, which basically has the same frame, the same structure, the very data that we have used to formulate the primal, that data is only going to be used for the formulation of dual. But the dual problem will be looking at the original problem with a different perspective, and this problem will have a different significance. So right now in this series, I will be telling you 3 things: how to write the dual problem of a primal problem, how to find the solution of a dual problem via a primal problem, and how to find the significance, how to understand the significance, the meaning of the dual problem by taking a look at the primal. So in this, my friend, one thing has already been done, that we have learned how to convert the primal problem into dual problem, how to convert the primal problem into a dual problem. Okay, so meanwhile, my friends, meanwhile, I was explaining you the rules also, whatever rules I have written here. So this rule has been explained, this rule has been explained. Now this rule, the coefficient matrix of the constraint of the dual is transpose of primal. So basically what I have done here, I have transposed this matrix. This matrix has been transposed, hai na? This was like this, the row has got converted into columns in case of dual. So I hope you understand that point. Now the next point was, the coefficient of variables in the objective function of the primal appears in the RHS of the dual, and the RHS of the constraints of the dual appears in the objective function of the primal. So what is this? I mean this 3, the coefficient of the objective function of the primal goes to the right hand side constraints of the dual, है ना, and the right hand side constraint of the primal goes to the objective function coefficient of the dual. ठीक है ना? So I hope guys, all the 7 rules are perfectly clear to you. All the 7 rules are perfectly clear to you. I hope you understood this. Sir, what does the meaning of primal equation? Sorry, primal problem, not primal equation. Okay, I have told you na. So you know the meaning of primal problem now. Now guys, let us move on. Let us move on. Let us take one beautiful question with the help of which I will be explaining you guys all the things that are there about the dual problem. How to find the solution of a dual problem, how to understand the significance of the dual problem. Just by one question we will be dealing with that. Okay, so let me move on. Let me just write the question for you. It is a very small question, will not take much time. So the question is, a company makes a company makes 3 products X, Y and Z out of 3 raw materials, out of 3 raw material A, B and C, comma, the number of unit of raw material and profit per unit of X, Y and Z is as follows. is as follows. There is A, B, C. There are products X, Y, and Z. It is 1, 2, 1, 2, 1, 4, and 2, 5, 1. So this is 40, 25, 50. Availability is 36, 60, 45. This is the profit. Okay. Now let me write the question from here, because you won't be able to see anything behind my availability of raw material. Determine number 1, number of units of X, Y, and Z to be produced for maximum profit. Second, write the corresponding, thank you Ashwin, write the corresponding dual problem. And third, shadow price or unit worth of A, B, and C. Okay, so this is the question, my friend. This is the question. So what it says in this question, that a company make 3 products X, Y, and Z out of 3 raw materials A, B, and C. Okay. Now the number of unit of raw material and profit per unit of X, Y, Z is as follows. The availability of raw material A, B, and C is given, that raw material A has only 36 units, B has only B has only 60 units and C has 45 units. Okay, so these are the availability of raw material A, B, and C. The profit behind 1 unit of X is 40 rupees, behind 1 unit of Y is 25, and behind 1 unit of Z is 50 rupees. Now for 1 unit of X, we need 1 unit of A, 2 units of B, and 2 units of C. Similarly for Y, we need 2A, 1B, 5C, and for Z, we need 1A, 4B, and 1C. Okay. So now they have asked us to determine the number of units of X, Y, and Z to be produced for maximum profit, that how many number of X we shall be making, how many Y should be making, and how many Z we should be making in order to produce maximum profit. And then they have asked me to write the corresponding dual problem, and at last they have asked me to find the shadow price or the unit worth of ABC. Okay, so guys, just leave the third part, of this question. I will be discussing that with you. Do one thing, है ना? First of all, you have to formulate a linear programming problem, which will be your primal, and then you will have to solve the primal using the simplex method. Because remember, in this question there are 3 variables. Even if you want, you cannot use the graphical method. Okay. So in this problem there are 3 variables. Even if you want you to use the graphical method, you cannot use, because you won't be able to solve this problem using the graphical method. So I hope you are getting my point. Okay, the next thing is that you have to find using the simplex method that how many x and y and z we should be making in order to make maximum profit, and then just simply write the dual problem of that very linear programming primal problem. So guys, I will be giving you all a head start of 1 minute. So please take down this question if you would like, or formulate the problem if you like, and then after 1 minute I will be start solving this question so that you guys can understand it. Okay, so go ahead. Okay guys, so let me join you है ना. So there are three products X, Y and Z, and the profit behind them is 40, 25 and 50. And remember, the objective is to maximize the profit. So I am going to write the objective function now. So the objective function will be to maximize profit, that is 40x plus 25y plus 50z. Okay, so 40x plus 25y plus 50z. So basically x, y, z are the number of units of products x, y and z. So behind 1 unit of x there is a profit of 40 rupees. So 40 into x, so the number of x that I will make will dedicate the total profit that has came from x. So we have to maximize this profit equation. Okay, now I will have to write the constraints. So I will be writing subjected to. So subjected to, that means there are certain limitations, restrictions, and the restriction that is there on raw material A is that we can only have 36 unit of raw material A. And remember, we need 1 unit of A for 1x, 2 unit of A for 1y, and 1 unit of A for 1z. So overall x plus 2y plus z should be less than equal to 36 है ना. So remember, the number of x, suppose I make 10 units of x, then I will need 10 units of a. Suppose I make 5 units of y, then I will need 2 into 5, 10 units of a. Okay, so this equation is basically showing us the need or the requirement of raw material a, and because there are only 36 units of a available, therefore this total value is less than equal to 36. Now I will writing the next equation, that is 2x plus y plus 4z less than equal to 60. Then 2x plus 5y plus z less than equal to 45. And at last I will be writing that x, y and z all should be greater than equal to 0. Now because I have to convert this problem into a standard form so that I can solve this using the the simplex method. So let's not waste any more time and straight away do this. Let's write this problem into the standard form. So all the variables are restricted, so no need to convert the variables. So let us simply convert the equations. So remember that in simplex method, all the equations are in the form of, all the constraints are in the form of equations. So this will become x plus 2y plus z plus s1 is equal to 36. Similarly, 2x plus y plus 4z plus s2 is equal to 60, and 2x plus 5y plus z plus s3 is equal to 45. And at last I will be writing that x, y, z, s1, s2, s3 all greater than equal to 0, and the objective function will also be modified and it will become 40x plus 25y plus 50z plus 0s1, 0s2 plus 0s3. Okay, so now let us start solving this problem using the simplex method. That means we have to perform the first iteration, and for the first iteration, remember x, y and z are decision variables, so they cannot be basis for the first iteration. So we will be selecting s1 from here, s2 from here and s3 from here for the first iteration as our basis variables. Okay, so let me write this, the first iteration, the first iteration. So this will be CB, CJ. Guys, this is the last question in this very chapter, and after this question, each and every one of us will be free from linear programming problem. At least I will be free, that I have taught you guys. Now it is up to you. So CB, CJ basis x, y, z, s1, s2, s3, b, this is s1, s2, s3, this is 0, 0, 0, and this is 40, 25, 50, 0, 0, 0. Okay, so now let me just write the constraints. So 1, 2, 1, 1, 36, 1, 2, 1, 1, 0, 0, 36. Then I have 2, 1, 4, 1, 2, 1, 4, 0, 1, 0, 60. And at last I will be having 2, 5, 1, 0, 0, 1 and 45. Okay, so let us write Zj then, because all these three are 0. So Zj will be 0, 0, 0, 0, 0, 0 and 0. So basically, when x, y and z are not in the table, so we have checked the value at the origin, because remember, if x, y and z are not in the table, so they are non-basis variables, and the value of non-basis variables is 0. Okay? So my friends, up until now, after the first iteration, my objective function, that is my profit, is 0. Now let me just find out Cj minus Zj to check whether this feasible solution is optimal or not, because this is the vertices point of the feasible region. So 40 minus 0, 40, 25, 50, 0, 0, 0. So this shows that out of these three, these are the positive ones, and 50 is promising me the maximum increase in the objective function. So I will make sure that 50 enters inside the simplex table and becomes the basis variable. So 50 is corresponding Z. So my friends, Z has become the entering variable, and now if some variable has become the entering variable, then definitely someone should go out, and for that we calculate the replacement ratio theta. So 36 by 1, that is 36, 60 by 4, that is 15, and 45 by 1, that is 45. So remember, we always select the one which has the least value of theta, because that only gives us the feasible solution. If I will choose any other value of theta, that will give me a infeasible solution. Okay, so let me just mark this. Okay, so now in the next iteration, my friend, Z will take the place of S2 and S2 will leave the table. Okay, so let us perform the second iteration then. So guys, whatever I am teaching, are you guys have any doubts? है ना? If you have even a slightest of doubt, just ask me in the comment box. Okay. So for the second iteration, let me just write the table first. So this is CB, CJ, basis, X, Y, Z, S1, S2, S3, T. So the basis column will be having now S1, Z, S3, S1, Z, S3, 0, 50, 0, 40, 25, 50, 0, 0, 0. And now to fill the table, remember we have to make this 4, that is the pivotal element, into 1. That means dividing this entire row by 4. So I will be writing the conversion here, that in order to get a completely new row 2, I take the old row 2 and divide that by 4. Okay, so let me just do that. So this will become half 1 by 4, 1, 0, 1 by 4, 0, 15. Now I have to make this into 0, this into 0. So what I will be doing, that in order to get a new row 1, I will take the old row 1 and subtract the old row 2 dividing by 4. And similarly for row 3, I will take the old row 3 and subtract the old row 2 by 4. So this will be giving me half 7 by 4, 0, 1, minus 1 by 4, 0, 21. Then 3 by 2. So this will be 5 minus 1 by 4, 4 5s are 20, so 19 by 4. Then 0, 0, minus 1 by 4, 1, 30. Okay, so now let me calculate Zj, my friends. So Zj will be 25, 25 by 2, 50, 0, 50 by 4, 0, and 50 into 15 is 750. So let us just simply verify that 50 was going to go inside and it was about to play 15 deliveries. So 50 into 15 is 750. So yes, we have got 750. That means everything is perfectly fine. Okay. Now let me write Cj minus Zj. So this will be 40 minus 25, that is 15. This is 25 by 2. This is 0, 0, minus 50 by 4 and 0. Okay, na? So only these two values are positive, and among these two, 15 is promising me more maximization, so I'll make sure that 15 goes inside the table. So 15 will become my entering variable. This will become my entering variable. Now somebody has to move out. So for that, my friends, I will be calculating theta. So that is 21 by half, that is 42. 15 by half, that is 30, and 30 by 3 by 2, that is 60 by 3, or 60 by 3 is 20. So out of these three, the smallest one is 20. So 20 will be becoming the leaving variable. So let me just make the box here. Okay. So in this very iteration, what are the values? So z is in the table, but x and y are not. So x 0, y 0, and z is how much? Z is 15. Okay. So z is 15. So this is the feasible vertices point, and this is not optimal because we have already seen that somewhere in Cj minus Zj some variable is promising to maximize, so that variable became the entering variable. So in the very next iteration table, x will take the place of s3 and s3 will go out of the table. Okay, so let me perform the next iteration then. Next iteration, that is the third iteration. So in this third iteration, CB, CJ, basis X, Y, Z, S1, S2, S3, B. In the basis column, I will be writing S1, Z, X, so 0, 50, 40, 40, 25, 50, 0, 0, 0. Now, this is the pivotal element. We have to make sure that we convert this into 1. That means for a new row 3, I will be taking the old row 3 and multiply it by 2 by 3. Okay. So here I will be getting third iteration, that is 1, 19 by 6, 0, 0, minus 1 by 6, minus 1 by 6, 2 by 3, and 20. Now above this there is to be 0, so let me make 0, 0 here. So this will become 1 by 6, 0, 1, minus 1 by 6, 1 by 3, 11, and this will become minus 4 by 3, 1, 0, 1 by 3 minus 2 by 3, and this is 5. Now let me write Zj then. Let me write Zj. So Zj will be 40, 60, 50, 0, 10, 10, and this will be 1050. Now let me calculate Cj minus Zj, but before I do that, let me write here that x is coming out as equal to 20, z is coming out to be 5, and y is 0. Y is not in the table. So Cj minus Zj, 0, minus 35, 0, 0, minus 10, minus 10. Okay. So now in the maximization problem, all the values are 0 or negative. So this solution, my friend, is an optimal solution to the problem, that I have to make 20 units of x, 5 units of z, and the maximum profit that I can make is 1050. Okay, so this is the end of the first part of this problem. This is the end of the first part of this problem. Okay, and what was the first part? Let me just show that to you, that what are the number of units of x, y and z we shall be making in order to make the maximum profit. Now I will be writing the corresponding dual problem. I will be writing the corresponding dual problem. So let me just do that. Let us make some space. Okay, so now the dual problem. So this is the primal, this is the primal. So now let me write the dual problem here. Let me make a line here. So the primal is maximization, so dual will be minimization. So now maximization problem, all the constraints should be less than equal to, so they are less than equal to, and all the variables are restricted, so no issues in that. So we can straight away jump into the conversion. So minimize W, which is equal to 36 y1 plus 60 y2 plus 45 y3 subjected to 1 2 2. So that is y1 plus 2y2 plus 2y3. Because this is minimization, therefore greater than equal to 40. Then I have 2y1 plus y2 plus 5y3 greater than equal to 25, and at last I can write y1 plus 4y2 plus y3 greater than equal to 50, and y1, y2, y3 all greater than equal to 0. So this is my dual problem. Okay. So let me continue then. So we have converted the primal into the dual. Okay. Now, before I proceed, let me just recall this to you, that in this problem here, x, y and z are the number of units of product x, y and z, and 40 rupees is the profit behind 1 unit of x, 25 is the profit behind 1 unit of y, and 50 is the profit behind 1 unit of z. Now what is 36? It is the availability of raw material A, 60 is the availability of raw material B, and 45 is the availability of raw material C. Okay, keep listening. Now my friends, if you will be looking at the primal problem, you know that 1A, 2A, 1A are the requirement for x, y and z, and because there cannot be more than 36A, so x plus 2y plus z should be less than equal to 36. So basically, because we know what is this 40, We know what is this 25, we know what is this 50. Therefore, therefore, by writing or formulating these equations, we can understand that what these equation means. What is the meaning of this equation? We know that. But now if I will look at the dual problem, if I will simply look at the dual problem, so here it is minimization W 36y1 60y2 45y3 and subjected to a constraint y1 plus 2y2 plus 2y3 greater than equal to 40. Now we know that this 36 has come from here, and 36 is the maximum availability of raw material A. 36 is the maximum availability of raw material A. Similarly, 60 is the maximum availability of raw material B, and 45 is the maximum availability of raw material C. And 40, 25 and 50, my friend, is the profit behind 1 unit of X, 1 unit of Y and 1 unit of Z. So can you guys tell me, and whatever I ask, please write it in the comment box, can you guys tell me that what is the significance of this equation? Or let me just simplify that for you. What is the meaning of these variables y1, y2, y3? Even if you will just tell me what is the meaning of or what is the significance of y1, y2, y3. I mean here x, y and z means number of unit of x, y and z. What is the significance of the variable y1, y2, y3? What is the significance of the variable y1, y2 and y3? Tell me. Guys, y1, y2 and y3 is the unit worth of raw material A, B and C. y1, y2 and y3 is the unit worth of raw material A, B and C. Now what is the meaning of this word unit worth? Listen to me very specifically, okay? Now check this out first. Check this out first. Then you will be able to understand this in a better way. So at the optimal solution, we have decided that we will be making 20 units of X, 5 units of Z and no units of Y at all. So we will be making 20 units of X, 0 units of Y and 5 units of Z. Now A, B, C that are required to make X, Y and Z are 121, 214, 251. 121, 214, 251. Okay. So now if I am making 20 units of X, so the overall the requirement for A corresponding to X will be 20 into 1, that is 20, and because there is 0 Y, so no. Then for 5Z I will be using 10. Have I written it correctly? 121, 214, 251. Okay. Okay. I have made a bit of a mistake here. So this is A, B, C, X, Y, Z. So because we have 20X, 0Y and 5Z. So considering A, for 1X I need 1A. So for 20x, I will be needing 20a, 0 here, and 5 units of z. For b, I will be needing 2 into 20, that is 40 units of b, plus 4 214 b है ना, 2 into 20 is 40, and 5z, 5 fours are 20, and c, that is 2 into 20, 40, 1 into 5, that is 45. So total, my friends, we have consumed 60 units of B and 45 units of C, but only 25 units of A. Now if you will check out the maximum availability of ABC, it is 36, 60 and 45. So 60, all the 60 has been consumed, all the 45 has been consumed, but out of 36A, only 25 units of A has been consumed. Only 25 units of A has been consumed. Okay. Now my friends, we can see that B is completely exhausted. C is also completely exhausted, but we have the raw material A with us. Now, remember, unless and until we have A, B, C in some specific ratio like 1 is to 2 is to 2 or 2 is to 1 is to 5 or 1 is to 4 is to 1. Unless we have A, B, C in these specific ratios, we cannot make X, Y, Z. And we can only make X, Y and Z unless and until we have A, B, C in these specific ratios. And we know that behind 1 unit of X, I can fetch a profit of 40. Behind 1 unit of Y, I can fetch a profit of 25. And behind 1 unit of Z, I can fetch a profit of 50. Now these raw materials A, B, C, let's say they are available in the market for 100 rupees. Let us assume this point that raw material A, B, C are available in the market for 100 rupees. But let me tell you one thing. Raw material A, B and C can be available in the market for 100 rupees. Even I will buy A, B, C from the market for 100 rupees. But if I will be having 1A, that is 100 rupees, plus 2B, that is 200, plus 2C, that is again 200, a total of 500 rupees has been spent for ABC in this very ratio, my friends. Then for everybody else, this could be 500 rupees in worth. For everybody else, this 1A, this 2B and this 2C will be 500 rupees in value. But for me specifically, for someone who can use ABC in this ratio and can make X, he can fetch a profit of 40. So that means for me, this is not 500. This is 500 plus 40, that is 540 rupees. I hope you people are getting my point. Yes, Rahil, tell me. I hope you people are getting my point. What I am explaining here is that if raw material A, B, C are available in the market for 100, 100 and 100 rupees each, and if I spent 100 rupees to buy 1 unit of A, 200 to buy 2 units of B, 200 to buy 2 units of C, so overall I have spent 500. If I want, then spending by 500 rupees, I can get raw materials A and B, C and C in this ratio. But remember guys, if somebody will come and ask me, give me this A, B and C for 500 rupees. Give me 1 kg of A, 2 kg of B, 2 kg of C for 500 rupees. I will say no. Go buy in the market. I will not sell it for 500. I will sell it for 540 rupees. Why? Because I know that by this 500, just by making X, just by using these raw materials in this ratio, I can make unit of X and can fetch a profit of rupees 40. So if I can make a 40 rupees profit by these raw materials A, B, C in this very ratio, then why will I sell it for 500? I will be selling it at a minimum of 540 or more. If somebody is ready to pay 550, go take it, no issues. But the minimum that I would be wanting, from 1A, 2B, 2C is a profit of 40 rupees. I hope you people are getting my point. So now remember, this extra 40 rupees that I am talking about, this profit that I am talking about, some part of this profit, this total profit is coming from 1A, 2B, 2C. So definitely some profit might be coming from A, some profit might be coming from B, some profit might be coming from C. So remember, A, B, C was 100 rupees each in the market. But because my calculation is that I can have a 40 plus from this ABC, so definitely for everybody else in the market it is 100 rupees, but for me it will be 100 plus that extra out of this 40 which has a portion of B or C or A. I hope you are getting my point. And suppose I divide this by 3 and I do not divide this by 3. Suppose I divide this by 5, I will get 8 rupees. Hai na? So why 5? Because remember there are 5 portions, 1A, 2B, 2C. So 8 rupees is the contribution of one portion. So from B, 16 rupees is coming out. From C, 16 rupees is coming out. And from A, I hope you are getting my point. 8 rupees is coming out. So my friends, this 100 rupees per unit of A is actually 108 for me. This 100B is actually 108 for me. This C is actually 108 for me. But I am doing this just to explain that to you guys. What exactly this ABC is for me, that I have to find out. And that, my friend, is the unit worth of A, B and C. A unit worth means value. For everybody else it can be 100 rupees. But what is the worth of raw material A, B and C for you? That is what we are about to find out, and that my friend is what Y1, Y2 and Y3 are representing. Y1, Y2, Y3 simply represents, let me just write this, Y1, Y2, Y3 simply represents unit worth of raw material A, B and C. Unit worth of raw material A, B and C. I hope you all are getting my point. So guys, time is already over. A very little portion of this topic is left, and that is to explain to you guys that how to calculate the value of Y1, Y2 and Y3. How to calculate the Y1 value of Y1, Y2 and Y3. So guys, let me just tell you that in the optimal table, in the final iteration table, the values of the slack variable, under the Zj row, that means these values, S1, S2, S3, these values 0, 10, 10 are basically the values of the dual variables Y1, Y2 and Y3. Okay, so I hope you all got my point. I hope you all understood that what are the dual variables. So basically the slack variables, they are the dual variables. The slack variable are the dual variables. And remember, I have told you in the starting of the session that slack variables has a significance. So slack variables, my friend, Y1, Y2, Y3 are the actual dual variables, and their values can be obtained from the optimal table. As I have said, if you can solve the linear programming primal problem by simplex method, the dual is already solved. So the value of the dual variables are 0, 10, 10. Okay. So I hope you all got my point. I hope you all got my point, and now you have understood that what is duality, what is a dual variable, and how to find the values of the dual variable. And even I have explained you how to find the significance of the dual problem. Okay. So my friends, that is the end of this chapter. That is the end of this chapter. There is a very small theorem, है ना? There is a very small theorem about duality, which is called as the duality theorem. We will be discussing that theorem in the starting of tomorrow's class, and it will only take us 2 to 3 minutes hardly. So after delivering that theorem, I will be starting work study tomorrow. Okay. So remember guys, tomorrow we will be starting work study. Tomorrow we will be starting work study. ठीक है ना? An important chapter in the Industrial Engineering and Operations Research module. So guys, for those who were not attending the linear programming problem chapter, I know because you have already attended that on my special classes. So please take down this, that work study is going to start from tomorrow. I will be notifying you on different platforms about this new session. So that's it for today's class. That's it for today's class. Let me sum up. So guys, there is a bit of an information for you guys, and that's it. That the information is that Unacademy is starting a new batch for GATE 2022 aspirants by the name of Evolve, and this batch is going to be both in English as well as in Hindi, and it is going to start on the 28th of December. Remember to use the code MMM10 to join this batch. A new batch by the name Ascend is also going to start. A new batch by the name Ascend is also going to start on the 28th of December for GATE 2023 aspirants. You can use the code MMM10 to join this batch. And guys, if you going to join these batches, you will have to opt for Unacademy Plus or the Iconic subscription. The Plus subscription, my friends, is an investment. Even the Iconic subscription, if you can afford to make this investment, do make this investment. It will show its value in future. You get benefits like weekly test, doubt solving sessions, rank improvement batches. In the Iconic package, you get benefits like a personal coach, study planner sessions, study booster sessions, personalized test analysis, as well as preparatory study material. Okay. Now, my friends, the Plus package for 18 months and 24 months is available in these prices, 38,500 and 44,000. But in this referral code section, if you will use the referral code MMM10, 10% will get discounted off immediately. So you will get the maximum discount of 10%, that the prices will reduce by 10% just by using this referral code. This is also valid for the Iconic subscription. For 12 months and 24 months, the Iconic subscription costs this much. But if you will use the referral code MMM10, these prices gets also discounted by 10%. Okay. So this is my entire team. If you want to connect with my team, just scan this QR code to join the Telegram channel of Unacademy GATE Mechanical PI XE. This is the YouTube channel that you are watching right now. Please subscribe this YouTube channel. Thank you guys for watching my session. Please like, share and subscribe. I will see you all tomorrow.